Okay, so it's day 19. It's Friday night. I hope it goes quickly so I can go to bed. That would be nice. And it will start in 20 seconds. Do. Alright, good. Let's see what they got in store for us today. You land at the airport surrounded by dense forests. As you walk to a high-speed train, the elves, the mythical again, they think their satellites got an image of a sea monster. Fortunately, the connection to the satellite is having problems. I mean, the message has been corrupted. The list of the rules valid messages should obey unless receive messages collected far. The rules for valid messages are numbered and built upon each other. For example, 0, 1, 2, 1A, 2, this. Some rules, like simple map to single character, the rules list of sub-rules that must be followed. For example, the rule 0, 1, 2 means that to match rule 0, the text being checked must match rule 1, and the text after the part that matches rule 1 must then match rule 2. Some of the rules have multiple lists of sub-rules separated by a pipe. This means that at least one of the sub-rules must match. The ones that match must be different each time the rule is encountered. For example, the rule 2, 1, 3 means it must rule 1 followed by rule 3, or it must match rule 3 followed by rule 1. Fortunately, there are no loops in the rules, so the list of possible rules we find it. Since rule 1 matches A and rule 1 matches B, rule 2 matches either AB or BA. Therefore, rule 0 matches AAB or ABA. Here's a more interesting example. Here, because rule 4 matches A, rule 5 matches B, rule 2 matches two letters that are the same, AA or BB, and rule 3 matches two letters that are different, AB or BA. Since rule 1 matches rules 2 and 3 once each in either order, it must match two pairs of letters. One pair with matching letters, one pair with different letters. Use 8 possibilities. A, B, A. Well, there are any options to this. The received messages need to be checked against rules which are valid, which are corrupted. Putting the rules and the messages together, this might look like this. So let us. Sorry, my computer just crashed. So this. Okay. And your goal is to determine the normal messages that completely match rule 0. The above example, this match, but this don't match. How many messages completely match rule 0? Okay, so let us think about it this way. Class rule. So we don't have tagged unions. Or some types. So what I'm going to do is fake one in an ugly way. From typing, import named tuple and list. Okay, so rule is either a literal, which is a string, which equals none, and or it is a let's say sub rules, which is a list of rule. No, which is a list of int. So ID, which is int. Sub rules, which is a list of ints which can't I get it. Or it is let me look at the input and see how it looks, because it could be or sub rules, or it could be a literal, or so sub rules is a list of int equals this, let's say, and I shouldn't do that, but I will. Null string equals none. Okay, and static method parse from line, which is a string, and it's going to give me a rule. And it's going to look like this and say rule ID rest equals line.strip.split on colon space, okay? And now here are the options. If rest starts with a quote, then return rule ID equals int rule ID, and literal equals, let's say, rest1 to -1. Okay. L if okay, if pipe in rest parts equals rest.split on pipe, otherwise parts equals let's say rest, and then in either case I want to return rule ID equals int rule ID, and subrules equals do this on the next line, and this is going to be ugly, but it's going to be int n for n in parts dot split for part in parts. Okay, and so let me run this and just make sure that let's say lines equals raw dot split on new lines, and rule dot parse lines 0. Just make sure these work. Rule dot parse lines 1. Subrule rule dot parse lines 2. Okay, that looks good. And now let's say a rule matches, and it's going to match some string s and rules, which is a list of rule, and that's going to be a bool. And if self.literal return s equals self.literal. Okay, so in the literal case, this is the only way to match. Otherwise, return any let's see. I want to think about it. If it has subrules, then what I want to do is say I'm doing this wrong. Let me look at the problem again. But I think I'm approaching this wrong, which is going to cause me a lot of trouble. So that subrules will be followed. Test row 1 and the text after the part that matches rule 1 must then match rule 2. Okay, and so I actually want to say tuple bool comma string, and we're going to return if self.literal and self.literal.starts, and let me just make sure that A, B, that's only 2 quotes. So, and S0 equals self.literal. Then return true and the remainder of the string. Otherwise, if there's a self.literal and it doesn't match, and S and S0, L of self.literal, let's just say return false and empty. Otherwise, but see, I don't think I want this in here, so let me take that out. So let me think about this. Otherwise, we have subrules. So for subrule and self.subrules, and each subrule is a list of ints, and I need the number to match all. No, I'm going to need to handle this differently. This is like another parsing problem that is going to cause me grief. So I want to do this completely differently. Like I don't want to do it like this at all. Okay, and what I want to do is the following. Def reduce rules, which will have rules, which is a list of rule. Okay, and it's going to give me a list of strings. Okay, no, it's going to give me a list of lists of strings, and so output I is valid strings. Actually, it's going to give me a list of strings. Returns valid strings for rule 0, because that's what I want to know, right? And what I want to do is say n equals num rules, and let's say literal IDs equals rule.id for rule in rules if rule.literal. Okay, so we want to start with the literal IDs. and now, like when I look at this example, I see 4 and 5 and 5 and 4, right? And 4 and 4 and 5 and 5, 4, 1, 5. Let me see if this works. While len literal IDs is less than n, let's say replacements equals this, for rule in rules, if rule ID rule dot ID and literal IDs continue. So that one we already know. And then let us say actually, let me change this again. See, literals equals rule ID rule dot literal for rule and rules if rule dot literal. Okay. While len literals is less than n, for rule in rules, if rule ID in literals continue, and now let's say subrules equals rule dot subrules, and now let's say subrules equals this for subrule in subrules, and let's say literals I for I in literals dot get I for I in subrule for okay. So I'm going to look that up, and I'm just going to say rule dot subrules equals that. And let's say actually let me change that again. For I in range len rule dot subrules, for n in rule dot subrules I, no, rule dot subrules I equals literals get n comma n for n in rule dot subrules I. Okay, so it's getting mad at me because I'm mixing strings and ints. So let me just take that out. N equals so I do that. If all is instance string for I and so let me do this. SubRule equals rule dot subrules I if this instance subrule string continue if all is instant string, if all is instant in string for n in rule.subrules I. God, this is such a nightmare. I'm having it's one of those days where this problem is probably really easy and I'm making it really hard. If all is instance and string for then rule.subrules I equals no, this is a bad approach. Yeah, 20 minutes and haven't gotten anywhere. So I apologize that it's one of those days. Let's see. Dot rules equals rules. Okay, so let's try this again, and check. So check self and s, which is a string, and is going to return a bool. And what I can do is as follows. Check self s string against rule IDs, which is a list of int, which equals 0, and it'll get mad at me because that's a so I want to check it to see if it okay. And so what do I need to do? I need to do if not rule IDs and not s, return true. So we've used all the rules. And otherwise, I want to say rule equals self.rules rule IDs 0, and rule IDs equals rule IDs up to 1. Okay, so I want to check it against oh boy, one of these nights. Why is this hard? This shouldn't be hard. So I want to match part against 2 and part against 3, or match part against 3 or part against 2. And I do that by consuming so let me call this continuations of self and s, which is a string, and it's going to return an iterator of strings. Okay. So let's see if this works. If self.literal and let's say if not s, return, so that'll be nothing. If self.literal and s0 equals self.literal, I want to yield s1 and then return. And then otherwise, I have these subrules, right? So for subrule in self dot subrules, and each subrule is, now I can go back and make it a list of ints again. And I need rules, which is a list of rule again. For subrule and self dot subrules, this might not work either. For continuation, no, this isn't going to work. Alright, why am I having such a hard time with this? This is not like a hard problem, but clearly it is because I'm not able to do it. Okay, so must match rule 1, must match rule 2, and then have multiple subrules. At least one of the subrules must match. So S, which is a string, and I'm going to punt on what this returns. And so again, one is a rule 2 matches. Okay, I'm going to, the problem is that if I generate these possibilities, and that's going to be like 2 to the 100th, which I don't want to do. So I do need to do it the parsing way. Okay, why am I having such a hard time with this? So to check AB, it has to match 4, 1, 5. 4 is an A, so that is okay, and that means that 1, 5 has to match that, which means B, A, B, B, B has to match either 2, 3 or 3, 2. So we'll check it against both. 2, 3 says it has to match 4, 4, 5, 5, so we'll check it against both, check it against both. Okay, let me do this. Check S is a string and rules is a list of rule, and it's going to return a Boolean. So let me think about this. From collections import deck. Okay, and what I want to do is I want to say Q is going to be a deck which is going to take S, and that needs to match rule 0. Okay, and I think this will help. while q s and rule IDs equals q dot pop left. Okay, I'm feeling good about this approach now. And let us say if not s and not rule ID, so there's no string and there's no rules, will return true. Elif not s, so the string is empty but there's still rules to match, will return false. And if the string is not empty, and I'll say not s, if not s and not rule ID, so that doesn't match. Sorry, I just want to continue. If not s and not rule IDs, continue. No, that's returned true. Elif not s or not rule IDs, then I want to continue. And then otherwise have both s and rule IDs. So let's say rule equals rules, rule IDs 0, okay, and rule IDs equals rule IDs 1. Yes, this is going to be a better approach. And so we'll say if rule dot literal and s0 equals rule dot literal, then q append as a candidate, let's say s1 comma subsequent rule IDs. Okay. And then otherwise, for subrule list in rule dot subrules, let me call it subrule IDs, q dot append, I want s now to match the subrule IDs plus the rule IDs. Okay. And then return false because we've checked everything. Okay, and so now what I need to do is I need to def parse raw, which is a string, and let's say rules strings equals raw dot split on double new lines. Raw rules, and let's say rules equals rule dot parse RR for RR and raw rules dot split on new lines, and strings equals raw strings dot split on new lines, and return rules comma strings. Okay, and so let's say rules comma strings equals parse raw, and for s in strings, print s, check s against the rules. So let's see if that works. True, false, false. So is that right? True, false, false. Let's just completely match rule 0. Okay, so I think that's how many? Assert that sum of check s comma rules for s in strings equals 2. Let me run this. Okay. Raw equals f dot read rules comma strings equals parse lowercase raw print sum check s rules for s in strings. Okay, let's try it. Not enough values to unpack. Why is that? Because I typed day18.text instead of day19.text. And this is too slow. All right. So let me do this. Let me try elif len rule IDs is bigger than len s. So each rule can match at most one character. So if we have more than that, it's definitely not a match. Let's try it again. Print len q. I'm going to regret doing this, but we'll try it. These are long strings, so it's going to cause me a lot of problems. So that didn't actually help. So 111, I need to be more aggressive about pruning these because it's just adding them all. If len q is bigger than 10, I just want to see how it starts off. So EV is 0, 0 expands to 1, 4, 5. I consume. 1 goes to 2 and 3, or to 3 and 2. I pull off the 2 and 3. It gives me something different. I pull off this, and it gives me something different. And so then I get here, and that works. Now I have BABA 0415, and if I use a stack instead? I don't know why that would make a difference, but so here's the really long one. It's 0. It gives me 9729 and 2104, 9729, 44, 92. So let's see, this is so this approach works, but it doesn't work because it's way too expensive. And so I need to think of a way to cheapen it up. And how could I cheapen it up? So it's not the queue that's the problem. It is the actual all the combinations to check. So we may have to just like reason outside of the system and say there's some really long ones. So okay, well here's one problem already, is that these are not in the right order. Seriously? What? Is that on purpose? Are you kidding me? Let me go back here and change this parse function. Let's say rules dot sort and assert that all rule dot id equals I for I rule in enumerate rules. Well, let's say good equals 0 for s for is in enumerate strings, print I comma s if check s rules, good plus equals 1, print good, and these can all be and let me get rid of that this thing here and just see what happens. I don't want to print them now. Oh my god, are you kidding me? That's such a... God, what a jerky thing. Measures are hard, right? Fix them, completely replace rules. (842) and 11:42:31 with the following. Fortunately, many rules might help to start looking at which rules always match the same set of values and how those rules are used. Okay, fix them, completely replace. Okay, so now 2. So rules 8 equals rule.parse this guy, and rules 11 equals rule.parse of this guy. And I can do this now. And let's see what happens if I do it naively. $3.14. All right. So I don't know why part 2 is hard because I use the same solution. Anyway, all right, that was rough. That was really rough. And why was it rough? One, because okay, well, one reason it was rough is because I assumed the rules would be in order and they weren't, and that was kind of like a dick move on their part, to be honest. Like it was, right? Because I mean, I know I shouldn't have assumed that, but I did assume it, and that, like it added. I mean, obviously it was impossible with the way they did it, but um, it it was stupid, and so I'm a little bit frustrated with that. But the second thing is that it took me a while to figure out what is the right way to um, do this branching. And so I have a rule that so that two things need to happen. One is if I want to match a character, then I need to keep matching the rest of the string against the rest of the rules. And if I have a list of rules, I need to make sure that they match, and then I get to the end. And then I can have multiple paths to go down, and so I have to do something to branch out along those multiple paths. And so, as you saw, I went down some really bad paths. Although I think the solution I ended up coming up with is good. Returns true if S is a match for rules 0. Okay. And so in order to do this branching, I basically have a queue. Queue of pairs remaining string remaining rules. And so when I start off, I have the whole string remaining, and I just want to match the rule 0. And so what I do is, take from the queue, take from the queue, and now, here we consumed the whole string and all the rules. So that's a match, right? If the rules said matches A matches B and the string was AB, then we'd end up with empty. Consumed the string or the rules, but not both. So this is a dead end. Continue. Let's see. Forget it and continue. And now, let me move that comment up here. Each rule can match at most one character, so if we have more than that, it's definitely not a match. And so now, now we're in the case where we have both a string and rules to match. So let's try the first rule in our IDs. And so now this is the case where first rule is literal, so it must match the first. So if it matches the first character, then add the rest of the string and the rest of the rules to the queue. Um, and then this is actually slightly a bug, but what I should have said, elif rule. I mean, it doesn't matter because the sub rules will be. Um, it's a bug, but it's not a bug because they represented things. You know. So otherwise, I have one or more sequences of subrules. For each of those sequences, um, I prepend it to the remaining rule IDs and add that new list of rule IDs to the queue with S. Um, and so it's your sort of standard, you know, just it's a breadth first search basically across rules. And if we get here, you know, Q is exhausted and never found a match, so return false. Okay. Um, and then arg. So that's that. And you know, what can I say? It worked. Like there were two problems. One problem is it took me a long time to figure out how I wanted to approach this. And this queue approach, I think it's a really nice approach, and I'm happy that I came up with it. But I went down some really bad paths before I came up with it. So that's always the danger when you try and solve these things in a live coding way, is that you're going to go down some bad paths. And I went down some bad paths. And then like I said, I'm still angry about the rules not being in the right order, because why would you do that to me other than like just to be a jerk? So not happy about it, but figured it out eventually. Uh, anyway, all right, cool. Well, that took a lot longer than I would have liked, but it's done, and I will see you tomorrow. Thanks for watching. Good night.